Greetings, Trig fans. All right, so today we're going to start on Chapter 3, Day 1. And what we're going to talk about today is something called Radian Measure. Okay, this is basically another method of measuring angles, so I'll write that out here. Another method of measuring angles. And we're going to do it in terms of pi. We'll actually talk a little bit about how we get pi in a second here. But I want to talk about what a radian is. Okay? If I draw a unit circle, and we'll just draw a circle. And actually, let's call it, when this is length r, and that length is equivalent to this length. Okay, when those are equal, so they're both r, then we can say, let's just draw this line here, that theta, okay, that angle theta is equal to 1 radian. So theta equals 1 radian. Okay, but again, that's when those are equal to each other. So the radius is equal to the distance of that arc length. All right. So if I put, basically, if I put a piece of string on this guy right here, that would be the same length of a string that's going on this. That is called 1 radian. Okay. So theta is 1 radian. And anyway, we don't use degrees now. We're not using degrees. We're using radians. All right. So let's talk a little bit. And again, this is used for mainly it's used in science and math and engineering. So you'll see it in a lot of different applications there. So let's talk about converting between degrees and radians. Okay. So let's keep this little picture up here. Do you guys agree the circumference of a circle? This is back in the day when you learned in geometry. Isn't the circumference of a circle equal to 2 pi r? Okay? So if I, in a unit circle, if I set my radius equal to 1, what's the circumference of that circle? Isn't it 2 pi? Okay, that means that's the distance all the way around, a circle is 2 pi. That's the circumference of the circle. So I can say 2 pi radians is equal to 360 degrees. Okay? Right? That makes sense, right? 2 pi radians is all the way around one circle. Okay? So I can actually simplify that. Can I just say pi radians? Can I divide really both sides by 2? Pi radians is 180 degrees. This, math fans, is your conversion. Okay, so pi radians equals 180 degrees. And I'm going to even highlight that because this is actually the most important part of this chapter right here, is converting between degrees and radians. Okay, making sure you know how to do that. All right, so pi radians is 180 degrees. And usually, like I know I have the word radians here, but usually we just say pi is equal to 180 degrees. This radians is usually unitless. You don't say radians. Okay? All right, so let's do some conversions here. If I want to convert 30 degrees to radians. Okay, we're going to use our dimensional analysis. Remember the thing you learn in chemistry that makes you sound like super smart? It's very exciting. I'm going to say 30 degrees times, remember it's 1 pi radian per 180 degrees, so we're going to say pi radians. And again, I'm not going to put a unit there, and 180 degrees in the bottom. So if you notice, the units cancel, right? The degrees cancel, and we have radians left over. So 30 degrees, and if I cancel, now don't give me a decimal answer here. That's going to be a 1, and that's going to be a 6. So it's pi over 6. Okay, it's pretty easy. And this is an exact value. Again, I don't want the decimal. Don't give me a decimal with that. It's not a good thing. But a lot of times radians, many times radians is left in terms of pi. So in terms of pi, because that's kind of how a radian came into being, right? It's we developed it with using circumference equals 2 pi r. All right, so that's pretty easy. That's your exact value, and it's pi over 6. Convert. Let's try another one. Convert 3 pi over 2 to degrees. So it's going the other way around. Okay, that's pretty easy. You're just going to 3 pi over 2, and it's really radians is on top, right? And you're going to multiply that by 180 degrees per pi radians. I'll just write radians just so you can see that the units cancel. Then, of course, we wrote it in terms of pi, so then the pi's cancel. And then that's a 2, that's a 1, and that's a 90. So the answer is 270, and make sure now you put it in degrees. Okay, it's pretty easy. Okay, so let's do one where you're using your calculator. So if I do convert 213 degrees, 15 minutes to radians. All right, and you're going to say in your calculator 213 degrees, 15 minutes times pi divided by 180. All right, now this is the deal, math fans. And the only time you ever use the degree symbol, so you will not use it here. All right, because you only use it when you have a minute, right? Minutes and seconds. Otherwise, you don't do that. Because if you have it in degrees or in radians in your calculator, all right, it'll actually convert that automatically 180 degrees. It'll convert it into radians and actually give you an error. So you actually need to type in just the way that it is there, 180, and not, so no degree symbol. Okay, so you type that. Now obviously you have to use it here because you have your minutes. All right, but if you multiply that out, of course, getting an approximate answer, you're going to get 3.7219. It's radians, but you don't even have to put radians. And this is, of course, an approximate answer. Okay, not too bad. And then, of course, I can tell you guys convert 3.582 radians to degrees. And it's simple. 3.582 times 180 divided by pi. Okay, and of course, when I'm having this pi here, you're going to use that pi button on your calculator. That's the most accurate that you have. Okay, please don't use 3.14. You're going to use pi button. Okay. Anyway, you push your nice friendly buttons there, and you get 205 degrees and 14 minutes using your DMS key. Okay, not bad. Okay, so let's talk about some radian measures that we're going to actually use a lot, because now we spent all that time, and I had you guys memorize 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90, all the different quadrantals, all right? And now you're going to have to work with radians. So hopefully you have all that memorized, and I'll kind of show you an easy way to remember it, but you have to deal with radians. So a lot of times what people do is they convert from radians back to degrees, but I'm going to show you kind of an easy way to do all these problems. All right, so let's kind of draw our circle here. And this is going to be 0 degrees and 0 radians. Okay, I'm not going to even put any units there. This first one's going to be 30 degrees, and if I convert that, it's going to be pi over 6 radians. Okay, the middle one here is 45 degrees, and that's going to be pi over 4 radians. And this one is going to be 60 degrees, and that's going to be pi over 3 radians. And then 90 degrees straight up here is going to be 90 degrees, which is pi over 2 radians. And of course you can keep going here to all the other ones, right? But these are just reference angles. This one's going to be pi, which is 180 degrees. This is going to be 270 degrees, which is 3 pi over 2. And then you come back around here, of course, and we're going to get 2 pi, which is just 360 degrees, right? Okay, so kind of a way to remember some of these different things is this. If you have 45 degrees, that's pi over 4. That gets the 4. Okay, anything with a 4 on the bottom, the reference angle is 45 degrees. Got to remember that. Anything with a 4. Okay, and if it's 30 degrees, that's going to be pi over 6. So you almost have to think opposite. Okay, it's not like it's 30 degrees in pi over 3 and 60 degrees in pi over 6. It's opposite. So the 30 goes with the 6. So that reference angle is 30 degrees. So basically, if you ever see a 6 in the bottom, the reference angle is 30 degrees. It's almost easier than degrees. Because if I gave you some nasty problem like theta is equal to 1,350 degrees, you'd be like, oh, geez, I don't know what the reference angle is. I've got to subtract 360, keep subtracting 360 until I get something between 0 and 360, and then I have to subtract to figure out the reference angle, and then I know what it is. But the nice thing about it is, whenever you see a 6 in the bottom, it's automatically 30 degrees. That is really sweet. So let me just kind of finish this up here, and then I'll explain what I mean by that. But it's really nice. Then if I have a 60 degree angle, that's going to be pi over 3. So that's just the opposite. Anything with 3 is a 60 degree reference angle. So I can give you any problem. I can say 257 pi over 6. And what's my reference angle? It's 30 degrees. Now you still got to do some work. Okay? That's what you're going to use to figure it out. It's 30 degrees. Of course, it's based off of pi over 6. But you still have to do some work to figure out what quadrant we're in order to get the sign correct. Okay? But that's just kind of a helpful hint on how to deal with 45, 30, and 60 degree angles. And then the other ones you kind of have to know as far as the quadrantals. So 0 is 0, 90 is pi over 2. Remember, it's halfway around. All the way around, this 360 is what the circumference is. So half a circumference is going to be pi. That's why pi is 180. A quarter of that circumference is half a pi, which is your pi over 2. And there's 3 pi over 2, which is 3/4 of the way around. All right? So let's kind of try a couple problems here. If I told you, hey, what's the sine of pi over 3 radians? Okay, well, that's in the first quadrant. That's actually really, really nice. I don't really have to do a lot of work. And you could, if you wanted, say, gee, I got to convert this to degrees. So convert 2 degrees. And you can say, well, that means and you could say pi over 3 times 180 degrees per pi. So the pi's cancel, and you get 180 over 3, which is 60 degrees. But remember I told you, math fans, if it's a 3 on the bottom, automatically 60 degrees. So really, sine of pi over 3 is the same thing as sine of 60 degrees, which is root 3 over 2. Okay? Here's another one for you. Tangent of pi over 6. Up 30 degrees. And we know, right, the 3's rule there. So isn't my reference angle root 3 over 3? And since I'm in the first quadrant, isn't that my answer then? Okay, not too bad, right? How about cotangent of pi over 6? Okay, now, this is like a really, really bad mistake. Okay, bad mistake is to do the tangent of 6 over pi. That's just as bad as saying the cotangent of 30 degrees and saying that's the tangent of 1 over 30 degrees. That's like really bad. Bad. Don't do that. Okay, cotangent of pi over 6 is the same thing that we did before, math fans. You're just going to say it's 1 over the tangent of pi over 6. Okay, that's not bad, right? And then, of course, tangent of pi over 6, as we just did, is root 3 over 3. So it's 1 over root 3 over 3. which, remember, you can kind of think back in the day, right? Cotangent is the opposite of tangent, so isn't that just root 3? Okay, that's not bad. Let's do a couple more here. If I do sine of 3 pi. Well, again, it's kind of like coterminal. So you're really subtracting 360 degrees each time to bring it down to something between 0 and 360. Or if you think about it, you're subtracting 2 pi. Same thing as 360 degrees, right? So that isn't this problem the same thing as sine of pi? And then think the quadrantals, right? Isn't pi over here? So isn't that 180 degrees? And remember, sine goes from 0 to 1 to 0 to negative 1. Oh, okay, so sine of 180, these are identical, that's equal to 0. Okay, that's not bad. Let's try another one here. Sine of 600, sine of 23 pi over 6. A little messy there. Sine of 23 pi over 6. And you're like, oh man, that's brutal. Okay, it's so much, man. You know, do I have to convert that? Well, we know what? What's my reference angle? Isn't it 30 degrees? Sure is, because there's a 6 in the bottom there, math fans. Okay, so I'm really, before we even figure anything else out, what's the sine of 30 degrees? Isn't it 1/2? So that's my reference angle, right? My reference angle is 30 degrees, so I know it's 1/2. Now I got to figure out the quadrant. Well, 23 pi over 6, a couple ways you can do it. You can subtract 2 pi each time. And don't you guys agree that 2 pi isn't the same thing as 12 pi over 6? Right? Because that's 12 over 6 is 2. So I can subtract 12 pi over 6 how many times? Well, it isn't one time, because if I do it twice, isn't that negative pi? I get negative values. So I get 11 pi over 6. That's coterminal. So 11 pi over 6 is between 0 and 2 pi. And if you look at this, let's kind of look at this chart on top here. Isn't 11 pi over 6 over here? Because isn't this, if I go back around again, isn't that 12 pi over 6? Right? So 11 pi over 6 is right before that. So isn't that in quadrant 4? And what is the sign, SIGN, where it's in quadrant 4? Well, isn't it negative? So back to our original problem, the sine of 23 pi over 6 is negative. So notice we're doing the same steps as we did before, math fans. Okay? Exactly the same steps, except now everything's in terms of radians. So my problem is truly, we said the reference angle is 30, so it's negative, and then my answer, so the sine of 23 pi over 6 is negative 1/2. All right, I know it looked a little confusing, but it's really not that bad. Let's try a couple more here. The tangent of, let's do 8 pi over 3. What's my reference angle? Isn't it 60 degrees? What's tangent of 60? Well, it doesn't rule, the root 3's don't rule there, so isn't it just root 3? Okay, so I know my answer for this problem is going to be something with root 3. Now, I don't know, is it plus or minus? Well, let's figure it out. Well, first of all, 8 pi over 3, that's bigger than 8 pi over 3 is greater than 2 pi. So I have to do coterminal. I have to subtract versions of 2 pi. And that means subtracting, what's 2 pi in terms of 3? Isn't that just 6 pi over 3? Do you guys agree with that? So I'm subtracting 2 pi, so I'm going to get 8 pi over 3 minus 6 pi over 3 is 2 pi over 3. Okay, so now it's good. So I know it's going to be root 3. Where's 2 pi over 3? Well, isn't this 1 pi over 3, 2 pi over 3, 3 pi over 3? So I'm here. I'm in quadrant 2. What's tangent in quadrant 2? Oh, it's negative. So what is the answer to this problem? Negative root 3. So I'm really, the only thing I'm doing here differently is I'm figuring out what the reference angle is based on that denominator, which actually is pretty easy, and then I'm figuring out which quadrant we're in. Okay, that's not bad. How about the secant of, let's do 25 pi over 4. Ooh, that's kind of complicated looking. Brutal, brutal. Okay, well, okay, it's not that bad. Oh, nice. I like that 4. What's my reference angle? Ooh, 45 degrees. Pretty sweet. Okay, and I'm going to get you guys to start working on reference angles pi over 4 pretty soon. But that's okay. It's 45 degrees, but it's pi over 4. And then you want to figure out what the sine. Well, let's figure out what the secant. What's secant of pi over 4? Which is really the secant, right, of 45 degrees. And you guys, I don't know, maybe you don't know secant, but you know cosine. So isn't cosine of 45 degrees root 2 over 2? And so secant of 45 degrees is just reciprocal, or as you know, it's root 2. So I know my answer is going to be something root 2. Positive or negative? I got to figure that out. So we're going to say 25 over 4. What do you subtract? You keep subtracting 2 pi. What's in terms of 4s? What is it? It's 8 pi over 4. So how many times can I subtract that? Well, can I do that 3 times? Because isn't 3 times 8 pi over 4 24 pi over 4? And I have 25 pi over 4. So if I subtract that, I just get pi over 4. Very good. So I'm right there in the first quadrant. So my answer is positive root 2. Okay, so I hope you guys kind of get the gist here of what we're doing, how to convert and find the sine, cosine, tangent. It's just the same as last chapter, except now you got everything in terms of radians, which is pi over 3, pi over 6, and pi over 4. All right, and of course pi over 2s are going to be one of the quadrantals, or if it's just pi, right, it's one of the quadrantals. So I guess here, one more here. If I cite sine of 11 pi over 2. Well, I'm at one of the quadrantals, math fans. And so what I'm going to do is I'm going to subtract 360, or 2 pi. Well, isn't that the same thing as 4 pi over 2? And how many of those can I subtract before I go to negative? Well, 3 of them is 12 pi, so that's not good. So I can just multiply that by 2. So I get 11 pi over 2 minus 8 pi over 2, which is 3 pi over 2. So my new problem is the sine, I'm going to write over here, sine of 3 pi over 2. Well, isn't that 270 degrees, right? Because I'm running out of room here, but I'll use a different color. Is this 0? Isn't this pi over 2? Isn't that pi? Isn't that 3 pi over 2 over in this one right here? So there it is. It's sine of 3 pi over 2, or sine of 270, which is negative 1. That's your answer. Okay. That's it, math fans. Again, it's practice knowing those. Pi over 4, 45 degrees, pi over 3, 60 degrees, and pi over 6, 30 degrees, and you should be good to go. All right. That's it, math fans. You have a great day. Adios. Bye-bye.